Remember, if you have any problems with anything in this presentation, please take a little time and rewind and go over it. Make sure that you copy down the sample problems and you work along with them and bring those sample problems to class. Isotopes are something that we've talked about already. We know that they have the same number of protons, but the number of neutrons are going to change. So when the neutrons change, the mass of the atom also changes. Today we're going to concentrate, if you have a sample of an element, then we're going to try to figure out that mass of that element by using the percentages of the isotopes. So what we're going to calculate tonight is weighted average atomic mass. When you look at the periodic table, you have an atomic mass. And that atomic mass is not a whole number. It's different from a mass number because a mass number is a whole number. Mass number is the number of protons plus the number of neutrons. Atomic mass, though, has a bunch of numbers after a decimal place. So we want to figure out how that's figured or determined or calculated. So we have the percentages of these isotopes that occur in nature, and then we try to figure out if you have a certain percentage that's higher, that's going to give you a mass closer to that number. So, for example, we have a sample of an element, copper, Cu. There's 30.8% of the atoms are copper 65. Means it has a mass of 65. And 69.2% of the atoms are copper 63. So those copper atoms have a mass of 63. What is the atomic mass of copper?
Of those atoms have a mass of 65. That's why we have dash 65. Then we have 69.2% of the atoms of copper are copper 63 with a mass of 63. So the way you solve this, you take the percentage and you're going to make it into a decimal. So I have a 30.8. I make it into a decimal by moving it 2 spaces. So now I have 0.308. And I take this 69.2 and I bring it over 2 spaces, and I'm going to end up with 0.692. I'm going to multiply by the masses. So copper 65, now I'm going to take that 30.8%, which is now 0.308, times 65. I'm going to take that 69.2%, which is now 0.692, multiply that by the 63 that we have. We're going to calculate that out. You end up having 65 times 0.308 gives us 20.02. And then the 0.692 times 63 gives us 43.596. And then you add the 2 numbers. You end up with 63.616. This is now the atomic mass of copper. We went from mass number of 65 and 63 to an atomic mass value very similar to what you have on the periodic table.
Here's our next sample problem. This is on the sheet that you have. The first problem, we have 80% of iodine with a mass of 127. Notice the number is in a different location, but that's still the mass. Then we have 17% of iodine with a mass of 126. And then we have 3% with iodine mass of 128. Here's our next sample, and then you're going to do the last one on your own. Make sure you write down all the information, work this problem out, and then you're going to show the last one in class. Here we go.
Sample problem, we have 80% of 127, so 80% iodine Notice it's not a dash number anymore. It's up on top like we find on the reference table. And then we have 17% of 126 grams. And then we have 3% of 128. Doesn't have to be grams, it could also be AMUs. So now we change those percentages to decimals. So over 2 spaces, we have a 0.80 times 127. Then we have 2 decimal places for the 17%. So it's 0.17 times 126. And then the 3% becomes, you have to add that 0 in there, 0.03 times 128. When we do our calculations, we end up with 101.6 for the first one. The second one, 0.17 times 126. We get 21.42. And then the last one, we have 0.03 times 128. You end up with 3.84. You take all those values, you add them up, you end up with 126.86. Now this is going to be our atomic mass of iodine. Very close, very similar to what we find on the reference table.
The next sample, number 6, that's the one you're going to bring to class that you're going to work on your own. You have 98% of carbon 12 and 2% carbon 14. Make sure you show all your work and bring that problem to class.